Hi, good evening.
This conference will now be recorded.
Hi, good evening, everyone. Hi, able to hear me? Okay, great. Yeah, Nandakishore, I see your message. Great. So, can all of you say hi once? Hi,
Hi,
Ganesh.
sir.
Yeah, hi, Ganesh. Okay, can you say hi?
Hi, sir.
Okay, great. Fantastic.
Hi, sir.
Hi, Anushka. Hi, Anaga. Okay,
Hi, sir.
so there are some procedure we should follow, and the procedure is that you please go through this guidelines. Able to view what is there in that screen. Hello, everyone. Able to view what is there in the screen?
Yes, sir.
Okay, so please follow this guideline. Yeah. Is my voice clear to all of you?
Yes, sir.
Okay, great. So there are few guidelines. As you see in the screen, it is mentioned. Uh, Still, I would like to repeat once. Is that during session you please mute yourself, and if you have any question, you unmute and then ask. Okay, so that will helpful to everyone to use the bandwidth very properly. Okay, thanks for your understanding. So now I'm going to start the question one by one. So in the last class, what we did, we discussed about those five descriptive questions. Today we are going to continue with the rest 15 MCQ question with one option correct. Okay, and any one of you is have any doubt on all those previous five questions, or if someone is new into this forum for today's session and they didn't attend the last one, please do contact us, and we'll be sending you the um the relevant material over email. So I'm going to start the first MCQ question. As you see in the screen, if velocity v, acceleration a, and force F are taken as fundamental quantities instead of mass, length, and time, the dimensions of Young's modulus of elasticity would be what? So this type of questions nowadays started coming in IIT JEE. As you know, that fundamental, quantities are what? Mass, length, time, electric current, thermodynamic temperature, luminous intensity, amount of substance which is mole, and luminous intensity which is in candela. But sometime to understand that how well you are aware of these fundamental units and the relations among themselves, the questions comes that okay, instead of mass, length, and time, okay, if we consider the velocity, acceleration, and force are the fundamental quantities, okay, then how the Young modulus will be represented. So those who are not very well versed with Young modulus, I would like to say that Young modulus is longitudinal stress by longitudinal strain. Okay, so let me write and explain. So if I write here, as a side note, is that Young's modulus is equal to longitudinal stress by longitudinal strain. So it is, you can say, stress and those who are in the class 11 or in first view may not be able to have a very clear idea about what is stress and strain. So but I will give you a brief idea about this thing. Okay, so now in longitudinal stress, how we compute stress is nothing by force by area, right? So if we write this longitudinal stress, so it turns out to be like this. That is equal to force by area, and the longitudinal strain is that what is the increment of length with respect to the original length, that is delta L divided by L. Now let's come back to our fundamental understanding about what is force by area. What is force? All of you know that force is nothing but M, L and T to the power minus 2, and divided by area is nothing but L square. I hope all of you are aware of it. Okay, and strain is nothing but length divided by length. So if you simplify this thing, you will get something like this. It will be M L power minus 1 and T power minus 2. Now, if you go back to the question, okay, we need to see that in the first option is F A square and V power minus 2. And let's see that whether F A square V power minus 2 is going to be equal to M L power minus 1 T power minus 2 or not. If it is, then option A is correct. We don't need to proceed with the other three options. If it is not, then you need to proceed further. So now, if we come to the first one, that what is giving in that F A square V power minus 2. If we look into the F A square V power minus 2, let's look into what is F. F we know M L T power minus 2. Okay, so this is one thing. Then it is coming that a square is acceleration, we know L into T power minus 2, and that is square. And then it is coming velocity V is L T power minus 1, and this power 2 power minus 2. Now if we simplify further, then what we'll get? We'll get the power of M is something like that. M power, what is coming? M power only 1, because there is only one M is there, M power 1. L power, it is 1 here, 2 here. 1 plus 2, and L is minus 2. So it is 1 plus 2 minus 2. Then T power minus 2. and it is minus 4, minus 2, minus 4, and minus 1 and minus 2 multiplied become plus 2. So it becomes t power minus 2 minus 4 plus 2. Okay, so this is our final thing in the form of ml and t, and that becomes m power 1. M power 1 means we can write m, and then L power, it is coming L power 1, and it is coming t power, minus 4. So m L power 1 t power minus 4, or m, you can write also m power 1, which is not equal to whatever the Young modulus we have derived. Young modulus we have derived with what? M L power minus 1 t power minus 2. You can write m power 1, so it is not equal to what is Young modulus? M power 1 L power minus 1, so t power minus 2. Hence option A is not correct. So what we see is that option A is not right. Now let's look into the option B. Option B, if we look into it, what is there? Is there f a square v power minus 3. Now let's do quickly f we all know, m l t power minus 2. Then a square is l t power minus 2 power 2. And v power minus 3, what is v? L t power minus 1 power minus 3. If you simplify this thing further, you will get something like this. So let me do in the next line. So if we simplify, then we'll get something like this. That here it is m power 1 as it is. So it becomes m power 1. Then L power, it is 1. 1 plus 2 minus 3. 1 plus 2 minus 3. And t power minus 2 and 2 is minus 4. So minus 2 minus 4 and t power plus 3. Okay, so what is coming here? Here it is coming m power 1, it is coming L power 0, correct, and t power, you see, the moment you see L power 0, you don't need to proceed further in MCQ because it is not equal to L power minus 1. And you can directly go to option C because option B is also not correct. But for the sake of completeness, what I can say is that m L power 0 and it is t power minus 3. Okay, which is not equal to what is the Young modulus is given. Okay, so what is the Young modulus here? It is not equal to m power 1, L power minus 1 and t power minus 2. So we see option B is also not correct. Then we should proceed for the option C. So let's look into the option C, how it looks like. Okay, so in option C, what we see is that if a square v power minus 4. Let's do it quickly. If we all know by this time very well, m l t power minus 2. Then we go to a square. A is acceleration, l t power minus 2 power 2, and v power minus 4. V is nothing but l t power minus 1 power minus 4. Now if we simplify this thing, what we'll get? We will get m power 1 and L power you see here is 1, here it is 2, 2 plus 1 plus 2 minus 4, 1 plus 2 minus 4. 1 plus 2 minus 4 become minus 1, so we have a hope that option C may be correct because so far M and L is actually matching. Then what is T? T is T power. Let's see T power, here it is minus 2, here it is minus 4, and here it is plus 4, minus 1 power minus 4, that is plus 4. So what we get? We get here is that ml and t power, we get t power minus 2, then minus 4, and then plus 4. So this is equal to what? This is equal to m power 1, L power minus 1, and t power minus 2, which is equal to the Young modulus. So we see that option C is correct, and you no need to proceed with option D because it is MCQ with single option correct. I hope all of you understood. and we can proceed to the next question. In the next question, the question is that the ratio L by R and RC, the ratio L by R and RC, where L is equal to, L is the inductance, R is the resistance, and C is capacitance, okay, have the same dimension as that of which among these four? Velocity, acceleration, time, or force? So let's see. So what is inductance? Okay, so let me write it down in details and then we'll have a discussion on this. Okay. So let's see, what is inductance. Inductance is generally denoted by Ln. This is nothing but, electromotive force, that is equal to EMF. What we say? It is EMF, electromotive force, divided by current divided by time. Correct. So this is called the electromotive force. That is called the inductance. Now, what is electromotive force? Electromotive force is nothing but equal to the electric potential. This is nothing but equal to electric potential divided by, current by time. So it is current by time. Now let's see what is electric potential. If we further synthesize, we will see the electric potential is nothing but work by charge. So we can write this as work by charge. And what is current by time? So let's see, current by time, let us keep as it is. So this is equal to current by, current by time. Now, if we further look into that, from here, if we see that what is work by, charge. So we can write this is equal to work divided by what is charge? Charge is equal to time into current. So this is time into current divided by current by time. So if we simplify further, we will see that time and time, get cancelled, and we get what? We get it is equal to work by current square. So this is equal to, we get work by current square. Now we know what is the dimension analysis of this work. Work we know that m L square t power minus 2 and divided by, we know what is current. Current is equal to current square, that means a square. So if we simplify further, we will get this is equal to m L square t to the power minus 2 a to the power minus 2. That is what we get as inductance. So that is Ln. Next one, we need to find what is the resistance. So what is resistance? Let's have a look into it. What is resistance? resistance is equal to, potential difference by current is equal to potential difference divided by current. Now let's see what is potential difference. As we already did it in the during calculation of inductance, is that potential difference is nothing but work by charge, work divided by charge. And what is current? Current, let us keep as it is as current. Now work by charge, if we do this thing little further, is this thing, what is work? Work as it is, let us keep work as work. If we keep work as work, then what will do? So it will be work divided by charge is nothing but time into current. Time into current divided by current. So if you look into this one, this is nothing but work by time into current square. So this comes to, so this is actually coming as work by work by time into just a minute. Yeah. So work by time into current square. So if we look into this thing, work by time into current square, so it actually turned out to be what is work? As we all know, work is ml square t power minus 2 divided by time is t, time is t, and we get current is equal to a square. So if we look into this thing, then we are getting, m L square t power minus 3 and a power minus 2. So now, you don't need to proceed further. If you do that, L by R, then what we get, you'll find this is equal to, nothing but time. Hmm. So, and a similar manner, if you do from the capacitance, that also you will get, the similar manner. So let's do it with that. With first one, let's do. Okay. So here I am going to derive this one. That that how we are getting the capacitance. So let's see that how we can derive capacitance. So as you know, the capacitance is equal to charge by potential difference. So what we can define is that capacitance is equal to charge by potential difference. charge by potential difference. So as you all know, what is charge? Charge is equal to time into current by work. Time into current divided by work and divided by potential, charge is equal to time into current. Sorry, I made as, just a minute. Charge we know that is charge is equal to, uh, time into current, that is charge. So we can write here time into current divided by, potential difference is nothing but, work by charge, as we have done earlier, that is work by charge. So now if we simplify further, what we'll get? We'll get it here, the time into current into charge divided by work. So time into current into charge, time into current into charge divided by work. So now what is charge? As we all know, charge is nothing but time into current, right? So it becomes time into current whole square, correct? So we all know from here, if we simply if we manipulate further, then you'll get this thing. So this becomes is that charge is equal to time into current, so it becomes turn out to be time into current complete whole square divided by work. Now time into current, okay, what is time? Time is t and current is a, so t into a whole square divided by work. Work we know, m L square t power minus 2. Now if we simplify further, we get something like m power minus 1, L power minus 2, t power 4 and a square, correct? Now let's see, so if you have a quick look into that, whatever we have done so far, we see we get this thing, that inductance ln equal to m L square t power minus 2 a power minus 1. So we can summarize, we can write in here. So what we get, inductance we get something like this. So we get here that ln, that inductance, hello, yeah, we get inductance. So ln equal to, so we get ln equal to m L square, we get ln equal to m L square t power minus 2 a power minus 2. Then we get resistance R, its dimensional analysis is m L square t power minus 3 a power minus 2, and capacitance C, it looks like m power minus 1 L power minus 2 t power 4 and a power 2. Now let's see what is ln by r. If we see ln by r, so ln by r, we are getting something like this. Ln, as we derived, m L square t power minus 2 a power minus 2, and what is r? It is m L square t power minus 3 a power minus 2. Now if we simplify this thing together, then we'll get, it actually turns out to be, t, because a power minus 2 a power minus 2 get cancelled, t power minus 10 t power minus 2 t power minus t comes to the numerator, it become t, L square get cancelled, get cancelled. So we actually come with t, which is nothing but the dimensional analysis of time. Similarly, if we make r into c, what is turned out to be? It is m L square t power minus 3 a power minus 2 into m power minus 1 L power minus 2 t power 4 and a square. Now if we simplify further, we'll see what m power 1 m power minus 1 cancelled out, L power 2 L power minus 2 cancelled out, t power minus 3 and t power 4 become t, a power minus 2 and a power 2 get cancelled out. So here also we'll end up with the dimension of t. So what we see out of these four options, if you look into the question, that ln by r or r into c has the same dimension as that of time. So we get the correct option as C. So we get correct option as option C. I hope things are clear with you. If you have any doubt, please do ask me before we proceed to the next question. So the next question we are going and okay. So the dimensional formula for latent heat, is out of these four options, which one? So we know the what is latent heat. Latent heat is nothing but heat per mass. So that is equal to heat by mass. So what we can write is that we can write here that latent heat is equal to heat divided by mass. Now, heat in the form of energy. So we can, make it equivalent to that energy by mass. We can write it that energy divided by mass. And as long as the dimensional analysis is concerned, we can make energy equivalent to work. So work by, we can say as mass. So what we see is that the dimensional analysis of latent heat is going to be the dimensional list of work by mass. And work we all know because we have done several times about the dimensional formula for work. It is ml square t power minus 2 divided by mass is m. Now if we simplify further, we will get got cancelled, which is nothing, so m power 0, we get L power 2 and T power minus 2. T power minus 2, and which is exactly what is mentioned in option A. So we get the correct option as A. So we get the correct option as A. I hope all of you understood. Now let's proceed to the next question. As we are doing our TDP on units and measurement, this question is from measurement. According to the question, the volume of a sphere is 1.76 centimeter cube. Then the volume of 25 such spheres, taking into account the significant figures, is what? So let's first do the computation. Then I'll come to that why the significant figures are important to choose the option. But if you see the options, especially the option B, option C, and option D, apparently it looks like same, because 44.0, 44, and 44.00, apparently it looks like all the three are the same. It is true as long as the numerical values are concerned, but as long as the expression of these values with respect to significant digits are concerned, then they are different, and we will see how they are different and what to consider to answer this type of question and what not to consider. So according to the question, the volume of one sphere is 1.76 centimeter cube. So let me write it here. So volume of one sphere is equal to 1.76 centimeter cube. So this implies volume of 25 such spheres is obviously 1.76 into 25 centimeter cube. So this will be equal to 44.0. Now, why we are not considering 44? Why we are considering 44.0? The explanation is the number, the volume of one sphere that has been expressed as 1.76, which has three significant figures. Whereas the number 44, which is there in option C, if you look into this number, that 44, this has two significant figures. Okay, and this one 44.00, it has four significant figures. So the point is that 44.0, okay, that is the correct one, because according to the principle of measurement, the result of that computation should be expressed in the number of significant figures which is given in any of the operand significant figures. Correct? So that is why, the result should always be expressed in the three significant figures, as the volume of the sphere, one sphere, is in three significant figures. So that is why 44.0 is the correct answer. So what we get here is that, we get option B as correct option. Now let's go to the next question. In the next question, it is mentioned that if x is equal to a power n, then the fractional error, that is delta x by x, is equal to what? So here I would like to explain the solution with the help of differential calculus, and you will see that how differential calculus is going to give us the result very effectively with a very minimal effort and minimal time. So as a background information, we see that it is mentioned that x is equal to a power n. That means x is a function of a, because n is integer. Okay, so x equal to a power n, here it is a function of a. So that means we can differentiate this x with respect to a. So we can write dx dA. Dx dA means what? D dA. Those who are very new to differential calculus, I can explain in little bit, elaborately. So d dA of a power n is equal to n into a power n minus 1. That's the formula. Now let's come from the fundamental definition of differential calculus. So how that dx dA is actually being defined? So that is called the finding the differentiation using the first principle. So if you see the dx dA, what dx dA represent? It is the rate of change of x with respect to rate of change of a, and that expressed in the concept of limit is if it limit delta a tending to 0, we are getting this one is that a plus delta A power in minus A power in by delta A. Whatever the limit I wrote here, that is the fundamental definition of differential calculus. So what we see? We see the limiting value. The limiting value means this value. This value of this is nothing but very approximate to dx by dx dA. Correct? So we can write something like this. Na? So this implies that A plus delta A power n minus A power n divided by delta A is nothing but dx dA plus a very small quantity called epsilon. Okay, so here you can write where epsilon is a very small number. Now what happened is that we can write that we just found it out that what is dx dA is equal to n a power n minus 1, isn't it? That we already found in the here we already found that dx dA is equal to n a power n minus 1 if you look into this portion. Okay, so from that derivation we can write that a plus delta A power n. Okay, so what we can write? A plus delta A power n minus A power n is equal to, okay, just a minute, it should be dx dA. Okay, just a minute, let me erase this part so that there will be no confusion here. So yeah, so what we get, so from this one we write this is equal to dx dA into delta A plus epsilon into delta A. Okay, now what we can write from here, that we know that x equal to a power n, so a plus delta A power n should be definitely x power n, sorry, x plus delta x power n. If x is equal to a power n, x is a function of a, so a plus delta A power n should be x plus delta x power n minus a power n is x power n. Yeah, just a minute. Yeah, so x is equal to a power n, so a plus delta A power n should be equal to x plus delta x minus a power n is equal to x, so that is equal to, we can write what is dx dA. Dx dA is equal to n a power n minus 1. Now we know from the the law of occurrence of error, both positive error and negative error can come with equal probability. So keeping this in mind, instead of writing dx dA is equal to n a power n minus 1, we can write this is equal to plus minus n a power n minus 1 plus minus n into a power n minus 1 into delta A. Now another point here, epsilon is a very small quantity and delta A is also a very small quantity. So if we multiply two small quantities, what we get is it is even smaller. So from a approximation point of view, we can ignore that value epsilon into delta A. So what we can write? We can just simply write that x plus delta x is equal to plus minus n a power n minus 1 into delta A. So in bracket as a logic we can write epsilon into delta A is is tending to 0 as epsilon tending to 0 and A is tending to 0. So from there what we get? From here we get that delta x is equal to plus minus n into a power n minus 1 into delta A. So from here what you can write? From here you can write that delta x by x is equal to plus minus n into a power n minus 1 into delta A divided by x is what? A power n. So from here what we get? From here we get delta x by x, that is a fractional error, is equal to plus minus n into delta A by A. Delta A by A. Since we can write this thing since A is not equal to 0. So we get this is the correct option. Delta x by x is equal to plus minus n into delta A by A. So we get the option B as correct. So we can write that option B is correct. So we get that option B as correct. So we get option B as correct. Now let us go to the next question. Next question is that a physical quantity is represented by x equal to m power a, l power b and t power c if percentage error in the measurement of m, l and t are alpha percent, beta percent and gamma percent respectively, then total percent error is which among these four? So here is the technique. The technique is called that by logarithm, and by using logarithm we'll see how efficiently we can find a solution to this question. So let us write here that what is given is let's assume it is already given x is equal to m power a, l power b and t power c. So for percentage error, what you need to find? We need to find delta x by x. That is in our mind. To find delta x by x efficiently, the first thing is that to perform logarithm, because we know that differentiation of logarithm is nothing but 1 by that one, means differentiation of log x equal to 1 by x. So from here what we get? We get log x is equal to log of m power a, L power B and T power C. And we can write from here log x equal to, we know the log, if I write in elaboratively, log, this is equal to log of m power A plus log of L power B plus log of T power C. This implies log x equal to A log m, because we know there is a formula log of m power n is equal to n log m plus B log L plus C log T. Now what we are going to do is that we are going to differentiate both sides. We'll get something very fantastic. Okay, so by differentiating both sides, we get 1 by x into delta x. Dx means delta x is equal to A into delta m by m plus B into delta L by L plus C into delta T by T. So now from here, if we do a percentage error calculation, so what we will get? We will get delta x by x into 100% is equal to A into delta m by m into 100% plus B into delta L by L into 100% plus C into delta T by T into 100%. So from there what you can write is that this delta x by x into 100% is nothing but the percentage error. So, and according to the question, the percentage error for m is given as alpha percent. So that means delta m by m into 100% is equal to alpha. And similarly, delta L by L into 100% is equal to beta. And delta T by T into 100% is equal to gamma percent. So what we can write is that delta x by x into 100%. So we write delta x by x into 100%, which is the percentage error we are going to find, that is equal to A into alpha plus B into beta plus C into gamma, that percent. And we get the option B as the correct one. So we get option B as correct one. I hope all of you understood very clearly, and let's now go to the question number 7. In question number 7, it is mentioned the density of a cube is measured by measuring its mass and length of its sides. So the density is not actually measuring by means of by mass per volume. Okay, so what it is getting measured? It is getting measured as a mass and the length of its sides, not directly in the volume, because that is the way the measurement is happening. Now, the maximum error in the measurement of mass and length are 3% and 2% respectively. That means if we consider that mass as m and length as l, then according to the question we get that delta m by m into 100% is nothing but the 3%, and delta L by L into 100% is nothing but the 2%. So what you need to find is that what could be the maximum error in the measurement of the density. Okay, so we can write that we know that the density the density, mass and length of each side of the cube, let the density, mass and length of each side and length of each side of the cube be d, m and l respectively. Then what we get? We know from this relation that d is equal to m by l cube. So what we need to find? We need to find delta d by d into 100%. So for that, the best thing is to perform that log d. So if we take the log d, as you know, it should be equal to log of m minus log of L power 3, that is minus 3 into log of L. Now if we differentiate both sides, what we get? We get that delta d by d is equal to delta m by m minus 3 into delta L by L. Now if you make a percentage error, then what you will get? Delta d by d into 100% is equal to delta m by m into 100% minus 3 into delta L by L into 100%. Now, what is the maximum value of delta m by m into 100%? According to the question, that is 3%. So, according to the question, what we see that its maximum value, is 3%, and its maximum value, that maximum value of delta L by 100 is that its maximum is 2%. Now, what we can do is that the maximum error should be what then? It is 3% here minus 3 into 2%. So that, as we know, that error comes both in positive and negative in equal probability. So in case the error comes in negative in case of delta L by L, so it is better to take their absolute value, because that is the maximum error according to the question. So the maximum error in measurement, so the maximum error in measurement is equal to 3% plus 3 into 2%. 3 into 2%. That is equal to total 9%, and the correct option is A. Okay. So hence we get the correct option as A. Good. Now let's go to the next question, which is question number 8. If you have any question, you can ask me. Otherwise, we can proceed to the next question, that is question number 8. The dimensional formula of modulus of elasticity. So, modulus of elasticity or elastic modulus is a quantity that measures an object or substance's resistance to being deformed elastically. That is, elastically means what? Non-permanently, when a stress applied to it. The elastic modulus of an object is defined as the slope of its stress-strain curve in the elastic deformation region. A stiffer material will have a higher elastic modulus. So this is the fundamental about modulus of elasticity. Now, the measurement of modulus of elasticity is done by a ratio called stress by strain. So what we can write here is that modulus of elasticity. So we can write here is that modulus of elasticity is equal to stress by strain is equal to stress divided by strain. Now in the very first question of MCQ we did discuss today, what is the stress? Stress is nothing but force per area. So we can write this is equal to force divided by area. And what is strain? Strain is that change in dimension by original dimension. Change in dimension divided by original dimension. Change in dimension by original dimension. Now, if you see the denominator, that is the strain, is the ratio of two dimensions, that is the change in the dimension by original dimension, and hence it is dimensionless. So, what we get, the dimension of modulus of elasticity is something like this. This is equal to, we know what is force. Force is ml t power minus 2. So ml t power minus 2 divided by area. Area is L square. And in the denominator, there is no dimensionless. So you can write dimensionless. So this turned out to be m L power minus 1 t power minus 2. And out of these four options, we see option C is actually matching with this one. So we get option C as correct. Let's go to the next question, which is question number 9. If you look into the question number 9, it is given the square of the speed of an object. The squares of the speed of an object undergoing a uniform acceleration a is some function of a and displacement. Whenever it is mentioned that it is some function of a and displacement, the way we should always express is something like this. We should always express like, that the speed, if we consider the speed as, v, so we should express something like this, that v square, sorry, that v square is proportional to a power m and s power n. So from here what we can write is that v square is equal to k into a power m into s power n, where k is a proportionality constant. So we know what is the dimension of velocity. Dimension of velocity we know as L t power minus 1. So L t power minus 1 square is equal to k into a is what? A is acceleration. So we know acceleration is L t power minus 2 power m, and s is displacement. Displacement is nothing but L power n. Now what is m and n? M and n are integers. Okay, it could be positive integer or negative integer or including 0. So now this equation what you see is dimensionally correct. So now if we further simplify, in the left hand side we get it is L square t power minus 2. In the right hand side we get k into L power m t power minus 2m and L power n. Correct? So from here what we can write? From here we see that is equal to L square into t power minus 2 is equal to k into L power m plus n, L power m plus n, and t power minus 2m. Now as we know the equation is dimensionally correct, so what we can say, but and at the same time k is a dimensionless constant. According to the question, the k is a dimensionless constant. Then what we can write? We can write is that L square should be equal to L power m plus n. So from the laws of indices, what we can write? We can write m plus n is equal to 2, and we can write minus 2m is equal to minus 2. Minus 2m equal to minus 2 gives us m is equal to 1, and that value of m equal to 1, if I write it back, so we get from here that 1 plus n is equal to 2, which gives n is equal to 1. So what do we get? We get m is equal to n is equal to 1, and m is equal to n is equal to 1 is the option B. So we get option B as correct. I hope all of you understood very clearly. Now let's go to the next question, that is question number 10. And in question number 10, the question is a physical quantity rho is related to the four variables alpha, beta, gamma, and eta as rho is equal to alpha q into beta square by square root of gamma into eta. Okay. Then the percentage error of alpha, beta, gamma, and eta are given as 1%, 3%, 4%, and 2% respectively. And with this given information, we need to find the percentage error in rho. So let's see how we can achieve this thing efficiently. So according to the question, we see it is given that rho equal to according to the question, we see the rho is given as alpha cube into beta square divided by square root of gamma into eta. So now from here we have done this kind of problem earlier today, so I can directly come back to this one. Is that delta rho by rho into 100% is equal to 3 into delta alpha by alpha into 100% plus 2 into delta beta by beta into 100% plus 1 by 2 into delta gamma by gamma into 100% plus delta eta divided by eta into 100%. So from here what we get is that if we do little simplification, delta rho by rho into 100% is equal to 3 into, according to the question, what is the percentage error of alpha is 1%. So 3 into 1% plus it is 2 into 3%. Why 2 into 3%? Because according to the question, the percentage error on beta is 3%. Plus 1 by 2 into 4% as it is given. The percentage error of gamma is 4%. Plus percentage of error of eta is just 2% as it is. There is nothing multiplication with it. So now if we simplify this thing, this becomes 3% plus 6% plus 2% plus 2%. So now if we add all these things, what we get? It is actually 13%. So we get the correct option as D. So we get the correct option as D. Okay. Now let's go to the next question, which is question number 11. The dimension of 1 by 2 into epsilon 0 into E square is what? So those who are in first PU or class 11, they may not be able to understand about by looking into this expression. So, what is epsilon 0? Epsilon 0 is called the permittivity of free space. This is also known as electric constant or vacuum permittivity or distributed capacitance of the vacuum. This is actually an ideal physical constant. It is the capability of the vacuum to permit electric field lines, okay, and its units is farads per meter. Now, how to find the dimension of this quantity, that is epsilon 0 into e square. So let's see how we can achieve this thing. Okay, so from electric charges and fields, we have this formula. The formula is called equal to E is equal to E is equal to 1 by 4 pi epsilon 0 into Q by R square. That is also known as F by Q0. So from here what you can write? From here you can write epsilon 0 into E is equal to Q by R square. So this implies epsilon 0 into E square is equal to Q by R square into E, that is equal to Q by R square into F by Q0. So from here what we can find is that, so the dimensional analysis of epsilon 0 into E, it is something like Q and Q0 that got cancelled. So F is nothing but that ml t power minus 2, ml t power minus 2 divided by L square. So that actually become m L power minus 1 t power minus 2. And that is what we get as option C. So we get option C as the correct one. Option C as correct. Okay, so now let's proceed to the next question, which is question number 12. So the question is, which of the following relations can be derived by the method of dimensional analysis? Okay, so we know there is a major limitation of dimensional analysis is that the given relation, any of the given relation cannot be derived using the method of dimensional analysis. That is, one dimensional analysis can only provide whether an equation is, as long as the equation and dimension analysis is concerned, dimensional analysis can validate whether an equation is dimensionally correct or not. But it cannot tell whether equation is itself correct or not. For example, let me give an example. So it will be very easy to understand. So we know from motion in straight line that the final velocity is equal to what? U plus a into t, acceleration, right? Now this is a correct equation as long as it is a dimensionally correct equation. Now with this, if we add any other quantity, that another velocity component, okay, suppose another velocity component, if we add something like that w, if you see, this could be a dimensionally correct, but that is not a correct equation at all. But if we validate this equation, we will see that it is dimensionally correct. So none of these four options which has been given is possible to make a judgment whether the equations, the relations are correct or not. So what we can write the answer as? We can write the answer as something like this, that one of the limitation of dimensional analysis, sorry, the limitation of dimensional analysis is it can't be used to check the correctness of a given relation. Hence, option D is correct. Okay. Now let's come to the next question. That is question number 13 of the MCQ and overall question number 18. The time dependence of a physical quantity. The time dependence of a physical quantity P is given as P is equal to P0 into e power minus alpha t square, where alpha is a constant and t is time. Okay, the constant alpha is what out of these four options? So let's see. So as we know that P is equal to P0, if you look into that equation very minutely, so we see that P is equal to P0 into e power minus alpha t square. Correct? Now P and P by P0 is dimensionless, and e power, obviously then that alpha into t square has to be dimensionless. So from there what we can conclude is that alpha into t square should have dimensionless, that means it is m power 0, l power 0 and t power 0. From there what we can say? We can say alpha is equal to just t power minus 2. So we get the correct option as B. So we get the correct option as B. I hope you understood this thing very clearly. Now let's come to the next question, which is objective MCQ question number 14, and overall it is in the, according to the test paper, it is question number 19. The question is, the value of 600 meter plus 600 millimeter with due regard to significant figures is what among these four options? So if we look into this thing, that the calculations and the different units, it is 600 meter plus 600 millimeter. So this is equal to 600 meter. Now let us convert that 600 millimeter. 600 millimeter is equal to 0.6 meter. So what do you get? Here you get 600.6 meter. Now there is a very interesting point. This volume has to be rounded off such that there is no decimal point as it is the case with the given two values. What are the given two values? The given two values are 600 meter and 600 millimeter. In these two values, we see there is no presence of decimal number. And according to the principle in the rounding off, the given values, that whatever the result we get, means based on the given values, whatever the result we obtain, that obtains the result thus we obtained should be rounded up to the minimal decimal representation of the given units, given numbers. Now as the given numbers has no decimal point, the resultant value 600.6 meter has to be rounded to the three significant digits without having any decimal values. Now if we look into this one, based on this principle, we will see that 600.6 meter to rounding off, it will come to 601 meter, and that is why we get the correct option C, despite if you look into the option D, it is exactly matching with the result what you obtained. This is the result we obtained, right? 600.6 meter. After that we rounded up to 601 because that is the principle of the rounding off, that I repeat, the result should have those decimal points which has the minimum decimal point in the given values. As the given values in this question has no decimal representation, so the resultant value we need to give in such a manner that it doesn't have any decimal point. So keeping this in mind, 600.6 has to be reduced to no decimal point representation, and that is actually 601 meter. So we get the correct option as C. I hope all of you understood this thing. Now let's come to the next question, which is question number 15 and overall question number 20, which is actually the end of this paper, the end question of this paper. The mass of a body, according to the question, the mass of a body is 20.000 gram and its volume is 10.00 centimeter cube. If the measured values are expressed up to the correct significant figures, the maximum error in the value of density will be what? So we have done this kind of problem, 2 to 3 times today. So keeping this in mind, if I can directly write this thing, that delta rho, the density by rho, is equal to delta m by m plus delta v divided by v. Now, according to the question, what is the delta m? Delta m should be 0.001 because that is correct up to the decimal figures, right? So it has to be 0.001 divided by what is m? 20.000. Correct? Plus delta v. Delta v should be what? Because it is 10.00, so it has to be expressed as 0.01, means after decimal there are 2 digits, means up to 2 decimal places, divided by 10.00. Notice here it was 20.000, so that's why we have given that 0.001. And here it is 0. Here as well it was that the volume was 10.00 centimeter cube. As it is after decimal there are two digits, so we also gave delta v as 0.01 because according to the question, if the measured values are expressed up to the correct significant figures. Now if you simplify further, we'll get this is equal to 5 into 10 to the power minus 5 plus 1 into 10 to the power minus 3. So this becomes 1.05 into 10 to the power minus 3. So keeping this in mind, so what we'll get, we can find the value of that delta rho is equal to 1.05 into 10 to the power minus 3 into rho. So this is equal to what we get. It is 1.05 into 10 to the power minus 3 into 20.000 divided by 10.00. Correct? Because that is what is rho, mass by volume. That is equal to, if we simplify it further, we will get 2 into 0.00105, and that will give us a result something like that. If we simplify, 0.00210 gram centimeter power minus 3. So that if we simplify further, that is coming to as 0.002 gram centimeter power minus 3. So we get the correct option as D, because none of them are matching. The first 3 options are matching. None of the first 3 options are matching, so we get the correct option as D. So with this, we are done with all the 20 questions as there was in that the unit test question paper. So I hope you all liked the session, and I promise as time goes by, all these things will be improved, and all of you will get to the detailed solution whatever I have discussed today in the class over email, um, or if you need it urgently, please do contact us, and we'll get back to you. Any assistance in future, do not hesitate to let us know, and we'll get back to you later on our next TDP session. Most probably we'll have on different chapter, and hopefully we'll enjoy it, and it will help you to make yourself a great preparation for your upcoming entrance examinations. Thank you very much. With this note, I'm going to end this TDP session. See you soon. Thank you.